Hoxworth Headquarters and got showed around by Angela Sturgeon. There she showed us the donation process and what goes on in the lab.
Okay, so this is a unit of whole blood that was derived from a single donor. This unit has red cells, plasma, platelets combined, white cells, everything. When it's taken up to the lab, you're going to see how we actually break these into its components. It's going to be separated into its red cells, its platelets, and its plasma. It's going to run through these filters, which are going to leukoreduce the product, which means it's going to remove the white cells from the product. Part of the immune system lives in the white cells. By removing it, it makes it safer for the recipient who's going to receive it at the end. There's less of a chance of a transfusion-related reaction if it's leukoreduced, okay? These satellite bags ensure that everything stays in a closed system, so everything that happens with this unit is going to happen within this closed system. The only opening was that tip of the needle that goes into the arm, okay? And the way we help reduce the bacterial contamination of the unit is we swab your arm before the needle goes in, and then there's a diversion pouch, which is now, it's removed from this since, but there's a diversion pouch off the side of the system, so the skin plug and the first, it's over there. So the skin plug and this first little unit's volume of blood that flows out of the arm goes into that pouch first. So if there was any contamination, it goes into the pouch before it goes into what the actual unit's going to be. And then we draw the test tubes, samples for infectious disease testing out of that diversion pouch. So those are all steps that we take in order to reduce the risk of bacterial contamination in the blood supply.
Red cells in a refrigerator. Hoxworth often has shortages of O negative because this is a universal donor. Type O negative has to be used for emergencies when blood testing is not possible.
Platelets are stored at room temperature in giant machines that shake them so that they do not clot. Plasma has to be used within 5 days, so they freeze it so that it lasts for a year.
In the lab, they separate the blood components and test for infectious diseases.
Okay, so when the whole blood comes from the blood drive or the collection site back to the laboratory, it is sat over here on this bench and separated and sat for a while. Once it reaches its time, it is rolled into the containers and then put into the centrifuges. Okay, the centrifuges spin it at a rate which separates the red cells to the bottom of the bag and the platelets and plasma to the top, forming a distinct line, which you can see in these units here. The units are put into these devices. When she's ready, she's going to crack the top and it's going to expel, it's going to push the platelet plasma solution up, out the top, into the second bag, okay? When the line reaches a certain point, she's going to cut it off because we don't want any red cells to get into this bag. We want to keep all the red cells in there, okay? Once that part's done, the red cells are then leukoreduced, hung over on the rack, and ran through the filter. That is what's going to leukoreduce the cells and remove all the white cells from that unit. Yeah, this one's going to be platelets, the plasma.
This one.
This is going to be the additive solution. Yeah. And then the red cells are eventually going to end up in this bag.
Yeah. Now this one will get made further down the road into cryo and cryoplasma. Both bags have labels on them.
So that just depends on, and they're told every day what they need to do based on what our inventory needs are.
Yeah. But it can't be no worse than 12 years a slave, you know? That movie was deep. Oh man, it was pretty intense. That girl did a good job though. Oprah was good in that movie though. Hey, yeah. Something else we got for a lot of that movie Nebraska. I never saw that. I didn't see that movie.